Hello, welcome on the Books Live talk. This is talk mostly about GLX and EGL stuff, so not that new Vulkan stuff, but still pretty cool things to have working properly. My name is David Heidelberg, and
hi, my name is Enrico. I'm one of the, as you'll see, many people who worked on this long story. I work for Red Hat, and I just have a small part in this.
So let's go. GLX standard, as you know, most of you, is a very old one, like from '92. And so far, if you're running X11, what you get when you run GTK application is exactly this window. You know, it's running some new OpenGL, some old GLX, and somehow it works. So that's nice. Let's move to EGL. So EGL first revision was released in 2003, and if you can see, this is like GTK demo running on X11 with EGL 1.5, and you can notice like small difference from the previous screenshot, right? You can see like if you look at the corners of the window, and there is small change when you run EGL on X11. And that's missing transparency, right? It's not that visible, right? Because it's just a sharp corner. But the trick is with EGL, you couldn't do the transparency. So what GTK developers did as workaround is like just sharp corner. So how we got into this? The first thing which happened is to get EGL, we needed transparency because that worked well on GLX. But with EGL, you couldn't ask for the transparency. You couldn't ask for the right thing for your window to do. So here I pass to Eric.
Yeah, so after this introduction, I want to talk a little bit more about what exactly is the bug we're talking about. And a simple description of it is that the applications which are using EGL on the X11 platform cannot request alpha blending configs or visuals. So somehow, up until recently, it was impossible for you to have an application which uses EGL, which will request that it will have, for example, the rounded corners, which you can render like with a transparent part of the corner. So that way you can have like shadows or like the rounded corners. For some reason, people really want that. Apparently, like the sharp corners are not good enough. And yeah, so if you have been using a Linux desktop, you see like, wait, but we just showed you. How does it actually work that we actually can get the shadows and like the transparency and all that stuff? Basically, even up until recently, up until this year, applications have been falling to GLX, and I'm not talking about like some random applications. Basically, Firefox, any application using toolkits like GTK had to fall back to GLX just because of this bug. And you might think it's a simple bug. Why don't you just like ask for the transparency? Well, as you'll see, it's not so simple. And this is especially a problem because even if we want to move forward, we want to move applications to EGL, of course, we want to move everything to Wayland. The applications still have to keep linking to GLX, which means we still have to keep providing GLX in our distribution, even if you're not going to use it, because even if me or hopefully all of you are not using X11 as to drive the display anymore, we still have to keep including GLX, which is, was shown is fairly dated at this point. So it's a maintenance burden for everyone to keep bringing it. But we cannot get rid of it because that's the only way you can have transparency. So can't you just request a format which has alpha? So if anyone here has written an EGL application, you request a format, that's going to be the pixel format you're going to use. And you can request a format with alpha. So isn't that good enough? Like, doesn't that just solve the problem? And it doesn't, because if you have an application which is on X11, you need to request something which is called a magic bit, which is something that there is no way for you, or there was up until recently, no way for you to request using EGL. And well, as we'll also see, it's not just a matter of adding something new to request the magic bit. It's more complicated than that, because that we could end up breaking old X applications, and we don't want to do that. So that's the whole reason it's so complicated. So why do we care so much about improving GLX if it's like super old and not many people using X11 anymore on their displays? Well, as I mentioned, we would really like to drop the GLX dependency from toolkits so that toolkits can move forward. Hopefully, we could have like a single backend. For example, we can only have the EGL backend for a toolkit like GTK, which is shared with the Wayland backend for the most part. And yeah, that's why we put so much effort in something which is so old and hopefully not used in modern applications anymore.
So let's go through the history, how it worked, like from 2013, and why we got merged just recently, the fixes which of the bug, which is around like 13, 11 years. So when the issue got reported, discussion started and people tried to come with some solutions. Most of the solutions was like differentiate between different visuals, different formats, and pass the information. But most of the issues was like breaking older applications, because we could always introduce new behavior, but we couldn't break applications which didn't know about this new behavior. So the fallback had to be always the default broken state until the application requests the compositor transparency. So here we go like through like timeline of how this evolved and how much effort went into this looking small change, which took few specifications and everything. So like first patch for this got released August 10, 2014. And you know, the revisions, it went pretty fast. So like, you know, 1 second revision, people reviewed, commented. But pretty soon they figured out that they need extension, and their Mesa Transparent Alpha extension was proposed. At some point, sent to mailing list. This we're still talking about old Bugzilla, not our GitLab. And but this was not a way, because like some people from NVIDIA commented and described how they do it, and that this solution couldn't work. So nothing got forward, but like we are now 2016, and people the bug got quiet, and people still was reporting bugs. They cannot get transparent compositing. So 2018, another try, and now we're getting closer to what got merged, and that's visual group selection. So right now we're saying, okay, we have a lot of visual formats, and the applications are used to pick the first format they want to use. And we cannot offer them this compositor transparent formats, because we break the application which doesn't know about this. So there was idea, let's put second group, which will be at the end of the list, and only these which say like, okay, I want a second group, they will get the transparent formats. It sounds nice, should work, right? So here is like, because it's a lot of parts which get touched by this, here is like also a history of like how Mesa CI interacted with it. So in 2000, because before all the tries was like people locally trying like run some test and okay, nice, now it works. Now we're getting transparency for our window. So like let's merge it. But with Mesa CI, we got a little bit of coverage. I think this is just build stuff, so that's not yet relevant that much. But here is a second breadth. So like Freya sending the extension proposal, the better one, and some suggestions. So looks good, right? We have first merge request. It looks good. It works. It works. There is some like review nitpicks. CI getting LLVM pipe testing, so at least like now something is tested. But as you see, it's not EGL testing, it's just GLS. And merge request is done, 2019, so everything is merged. And why do we talk about this right now? Because merge request looked good, mostly worked, but Intel CI is not happy. So Intel CI runs EGL tests, and it's failing for them. So that's not the CI, the Mesa CI. It's like local Intel own CI. So the report got a little bit later to Mesa developers. So at some point, also Raspberry Pi developers getting hit by this issue, and it gets reverted. There is, I think at that point, Freya got lost interest or got burned out of it. And so Adam Jackson rebasing the merge request, but it's still in the same state. So nothing to do. Firefox getting hit by this issue, so they have to use GLX calls to request a visual because EGL cannot provide that. So Firefox is okay with using EGL. They just have to call one thing in GLX and then use it in EGL. That's not great. After some time, like as you can see in 2021, Robert picks the merge request, rebase, and try to work on it and try to move it forward. So he also working on Firefox development. So he tried to send some patches to detect the extension and to behave correctly with transparency. Also, by the way, he discovering another bug in GNOME Motor compositor, which is nice. So working on open source stuff, you find bugs. At this point, Mesa 3D getting EGL testing, which is probably something like small subset of tests, but it's very important for us. You will see it later because otherwise we wouldn't be probably where we are currently. Specifications, right? So at this point, we're getting the extensions officially committed to EGL registry, so like it gets official. Specifications ready. Discussion. Yeah, right. Of course, GTK, as you could see in the first screenshots, got problems with missing transparency because they cannot switch to EGL. Yeah, there's some small feedback from NVIDIA because of like some enums was like in their block range. So you always need to have your own block for your extension, and you cannot drop it into NVIDIA stuff. So there has to be adjustments. And extension is there. So we have config select group selection. This selection is the thing which added the number. So all the visuals you have right now, they are like in group 0, and they are like the same visuals you got before, like 5 years before. But what you're getting now is group 1, and that's the extensions at the end, which you can use for this transparency stuff. So we have the EGL test. There is like pushes into it. No, merge requests are not happy. CI is not happy. And so at that point, I just like got it. I think because I was trying to do some epitrace stuff and doing some traces of applications. And I hit this issue with where I needed like some combination of EGL and GLX. And when you need to, when you're using epitrace, you specify if you use EGL or GLX. But the epitrace is really not expecting you use both at once, because like applications shouldn't do that, or like there's not much reasons to do that. So I got hit by this. So I was asking, like, you know, is it still relevant after, I don't know, like 80 years? And yeah, I've been told yes. So so I started being interested a little bit in this issue because I was like, you know, it's like annoying to have GLX around. So at that point in Czech Republic, we had some HDR Hackfest. And so a lot of people came to Brno, including Robert Mother. I stopped by there, and Enrico lives there. So that was easy. So I was having this issue on my mind. So we sit down, and we started like figuring out if we can like move it forward.
Yeah, so that's actually the part where I got involved with this. There was a Hackfest, and people were working all sorts of stuff. I met the two guys working there on this, and they were having problem with the CTS. They asked me if I have worked the CTS before, and it's like, yeah, I did submit 1 or 2 patches to the CTS, so I guess we can try to see what needs to be done. The problem is now we have this new extension that was mentioned. Basically, if you ever run EGL info, like if you ever worked with an EGL application, you run EGL info, you get like this list of formats that you can choose, and you have like all sorts of different number of bits that you use for like red, green, blue, alpha components, and a bunch of other stuff you can filter for when you choose an EGL config. And basically, what we added here from the extension is now we have one additional attribute, which is a select group. I'll show you later on a short demo that every config now has one of these extra attributes. And if you ever looked at how the EGL handles this, there are a bunch of rules on how these configs are sorted on the list of configs that are available. And this sorting is very important because applications can rely on that to choose, for example, the first one on the list to use. So basically, after a couple of hours, even trying to understand like what exactly is the issue, why is it so complicated to have transparency in EGL, we found out that what we actually have to do in the CTS is not so complicated. We only have to account for this new attribute and make sure that the CTS is happy with the new sorting of configs. Basically, the CTS is a test which will sort by itself the configs, and it needs to know that there's this new rule defined by the new extension. As long as we add that, the CTS will be happy. So it's not like we need to define a bunch of new tests or anything. We just need to make the CTS aware of the new sorting rules from the extension.
Thanks. So one of the approaches when you have like really big merge request, or at least when you have complicated problem which like requires a lot of time, a lot of thinking, is trying to go commit by commit, or at least if not every part of the merge request is dependent on each other, it's nice to merge at least something so you know the right part is already inside and it's verified and you can just focus on the rest. So there was like some small commits regarding the non-double buffered formats, which Adam Jackson ensured it looks like solid and should get in. So at least we offloaded like 1 or 2 commits from the merge request. Got merged, which was nice. And at some point, there was one thing we could test with CTGLS suite. But what about real use cases? So at this point, like Robert Mather found like 2 cases where you can test like visually that the feature working properly. Because one thing is to test the CTS test passing. Another thing is like if the application still gets the transparency, which explicitly the CTS test not asking for. So we got better documentation how to test, which is useful. And you can see like from previous slide where I mentioned I sent the CTS fixes through GitHub or GitHub, right? Yeah. So that got rejected because I was working with Collabora. So when you're working with partner, you need to submit through Gerrit, Kronos Gerrit. So that was like a little bit, detour. But at some point, I managed to submit the test. I mean, it's kind of challenging when you don't do it for like before or when you don't work with Gerrit, because it's like very different environment from GitLab, but can be done. It's just a little bit more work. What was nice, meanwhile, as we work on this, Daniel Stone at some point did some cleanup around, which was not directly related to this code, but it cleaned up a lot of stuff around, so you can nicely better focus on the, what's wrong with the code we have. We can test the merge request. So when we had the CTS patches, they were not merged yet, I think, or they were merged but not bumped yet. So what is nice about Mesa CI, when you have some new patch and you need it for testing, you can always go to the CI team, which I was part of it back then, and ask them like, oh, can you drop this patch for me? Or you can just drop some patches earlier into our testing. So that's why we did. That's what we did. Yeah. So we've been thinking like, okay, it's still like not fully passing, but maybe part of the merge request will work. But for this part, it was not possible. It was like already too much connected to other commits, so we couldn't merge just part of it. We had to like stay with the full merge request. And at this point, that's like we are already 2024. So I was just looking at the code, and at some point I said like, okay, it's like we copying the formats, the second group, but the trick is we don't need non-alpha formats. We always need transparency. So I did some adjustments, which needed to be right. Yeah, okay, right. So yeah, I did some small adjustments, but the specification and stuff will be a little bit later. And March 24, it passed. So like CI is green, transparency is there. It's like, after a long time, it works and nothing complains. That's so great, right? You would say like, again, we are at the end of the story. No, we are not. No. I will not take it for longer. So reviews. At this point, you start playing the game. Please review this merge request. And I mean, like, it's X11, it's GLX, related. It's EGL, but like not many people are interested in the like reviewing that part of code. So it's like really like, do you remember how I remembered this for you? And here is my code. So at some point, we got reviews, but Eric noticed we don't have specification for the visual ID. So he quickly wrote the draft. So we have now 2 extensions, one Mesa, one AGL. And, you would say everything is so nice until Intel people tell you, well, our CI failing with this. So first thing is, okay, we need to backport because Intel using stable versions of CTS. So we need to backport our fixes to their CTS. So that's been done. And right, this is like jump a little bit off. Do you remember EGL output, EGL info output? You have hexadecimals IDs, right? And if you look at the QP, when the EGL test fails, it always produces decimal output. So it's pretty annoying when you try to compare it and look why this format is added, and like it's very easy when you see hexadecimal which has like letter in it, but when it has only numbers, it's pretty annoying to think all the time about, okay, this is hexadecimal, it's not decimal. So I opened merge request to EGL info to produce also decimals because it makes your life easy. So the trick is Intel CI got patched by our sorting, but for some reason it was still failing. And the difference was they was using GLVND. And you would say like, what changes? Like what different? Like you just use GLVND, it's like no functional change in the code, right? Anyone has guess what could be why it was failing on that when like everywhere else it worked? So okay, I will give you some hint. So GLVND itself has some list of extensions. Well, okay, I will answer that. So the trick is the GLVND itself. So it was client extension, and the GLVND, when you ask it, it will like proxy the extension list. And the extension, of course, was not in the GLVND list, so it just dropped the extension. So, you know, that's easy, right? You go to GLVND and you added an extension. But Kyle Brenneman pointed out the EGL specification needs to be corrected. So what we had client extension. So it was originally client extension, but it should be display extension. So that means we don't need to do any change to GLVND, but we need to do small change to specification and fix it there, and small fix the GCTS tests. So change in registry gets accepted. Our tests are green, Intel tests are green, and it's merged. Ta-da! What a lovely story. So then what you do, you quickly talk to Eric a little bit about like, can we still merge it? We have like shitload, sorry for the strong language, we have a lot of testing already done. Do we make it? And he said yes. So it got in, and Mesa 24.1 has this resolved, and there is not much reason to use GLX for anything now. Also, so we kind of backported the fix for the client versus display extension to our CTS, CI CTS. So that got merged a little bit later, but definitely correct. Fix it. Yeah, it's the nice stuff, useful sometimes. And yeah, should I pass it? Okay, so lesson learned, why we're talking about this. The beginning of this issue was mainly problem with missing CI, because like you had no testing, you really merged something which was already broken. I mean, like, worked for most of the cases, but was breaking something. So when I started working on this personally, if I didn't have CI, I would be I would probably like send something which was buggy anyway. So it helped a lot. And you know, nobody wants to work on X11 or something related to it. So if you need to push some merge request, it's more pain. And but what I find very interesting is really like the free and open source development model, because imagine doing that for like even open source software, but without issues, without history of the issue, without the progress. If you just came to some projects with code without any information about it, I think it would be like no one would go for it to fix it. If you have the history, if you have the pipelines, if you have the issues, you can like grab to something and, you know, make it working in the end. And okay, the best news at the end is like there is no reason currently to use GLX. I think it's like even on X11, it's like you can drop it. It's fine now. And now demo, I passed to Enrico.
Let's see if this will work. Okay. So I have a demo here with before and after, just trying to run some GTK application. This is the script I'm going to run. It's just, I'm not forcing anything. So basically, the first run is to run the GTK demo with 24.0 before the patch. You see, everything works. We have, most important to see here is we have these rounded corners. But if we go and see, it fallbacks to GLX. This is not old GTK version or anything. It's the version in the current Fedora. So even today, if you're running this and you're falling back to X for some reason, you're still using GLX on modern toolkit. Now, okay, let's just see. I can force EGL. Just passing this GTK debug GL EGL. So let's see what happens if I try to force that. It still works, but it knows that it cannot do the transparency, so it falls back to these sharp corners. Oh. Where is it? Okay, yeah, it's using EGL, but it has to fall back. And now, what everyone was expecting, everyone's been waiting for, it's running with EGL. I didn't force EGL on this one, so it just picks it by default now. And it still supports that. We can see a little bit more of details. Hopefully this will be readable. So if you ever looked at EGL info output, this is what it looks like. This is just a comparison of two different Mesa versions, 24.0 and 24.2. This is what it normally looks like with the configs, and it shows you here the attributes. What we have now is this end of the list, which has a bunch of more configurations. These are actually copies of the previous configurations, and they are added at the end of the list, specifically with this attribute 1 here at the end. This is the new attribute provided by the extension, provides the select group. So the select group extension is needed here because we don't want these configs to end up in the middle of the other ones. That way, if you run old applications which use EGL, they could accidentally pick these attributes. And what's so special about these attributes is not necessarily that ID, but it's this. this is what is the visual ID, and this is the magic thing that is needed so that you can tell your compositor that you want to blend this window during the composition process. So it's important to note here again that this is not about having applications which can use an alpha component. You can still render your game or whatever, like you can still get a format which has an alpha component, but it would not be blended down by the compositor when it's compositing your whole desktop. It's only blended down if you would use this attribute. And the reason this took so long is that we couldn't just put these formats with the attributes in the middle of the other ones so that they could accidentally get picked. So it only took 2 extensions to EGL so that we can put this here at the end. And it doesn't get picked accidentally, but the applications which know about this can specifically request this. The second extension that we have is actually because you could not request an EGL config by a specific visual ID. You could, for example, request 8 bits for red, or you can request alpha, like 0 or 8 or 16 or whatever. But there was no way for you to tell EGL, no way compliant to the spec to tell the EGL that you want a specific visual ID. That's why we have the Mesa extension. So now it's valid to pass a token which says, give me this visual ID, and you can do that. That's basically it. Any questions?
Sure, I have a question. So the expectation now is that distros can just ship with fewer dependencies, make their systems a little lighter, make their builds a little faster and easier. Is that right?
Yeah, not only that, but you could also potentially like delete a lot of code if you would have an application which has like both a GLX code path and an EGL code path. Perhaps you were keeping it just because you needed the transparency, so now you would no longer need to have the GLX one. In addition to not, for example, distributions, like in the future, let's say, if nothing is using GLX anymore, now you could drop it.
Sure, thank you.
So mostly people were using GLX, and that was because of transparency, effectively?
I guess you could still have like applications explicitly want to use GLX, but the problem here was that like toolkits, for example, GTK, had to use it and had no choice to drop it, even if they want to get rid of the dependency because of this.